All right, stepping up the difficulty again in 7.4 example 3 is now we're looking at a quadratic. So f of x is no longer, nice is not the right word, but it's no longer the simpler linear function. Now it's a quadratic function. And the four-step technique that I wrote in example 2 will still work. But I think there's a lot of, I don't know about grunt work is the right word, but there is a lot of work that we can do beforehand because it does help quite a bit to identify some of these things. Part A is never more complex than that. 1 over f of x is going to be 1 over the original function, which is x squared minus 4. And, part B really lends itself to part A. As soon as we look for non-permissible values from chapter 6, try to remember that the denominator can't be 0. So that means that x squared minus 4 cannot be equal to 0. A couple different ways of solving this. I like factoring the best. That's a difference of squares. So it factors into x plus 2 times x minus 2 can't be 0. That lets me know that x minus 2 can't be 0. X plus 2 can't be 0. So x cannot be equal to 2, and x cannot be equal to negative 2. Those are the non-permissible values, which are where the vertical asymptotes occur. Now, I would like to point out really, really quickly that if I drew f of x, which is x squared minus 4, it looks something like this. This point right here is at 2 comma 0. This point right here is at negative 2 comma 0. So that relationship that we talked about in the previous example still is maintained, that the x-intercepts of f of x become the non-permissible values and therefore the vertical asymptotes of our reciprocal function. All right, C wants us to determine the x-intercepts and the y-intercepts of the reciprocal function. Keeping in mind that our reciprocal function is 1 over f of x is 1 over x squared minus 4. We're going to look for x-intercepts, and then we're going to look for y-intercepts. And I probably gave myself too much room. Remember that x-intercepts are where the value of the function, and I'm just going to maybe write this beside it, that if you wanted to use your calculator, this is what we would have to use. Y equals 1 over x squared minus 4 is the reciprocal of f of x equals x squared minus 4. Now, if I'm looking for an x-intercept, I'm going to put in a bracket behind it, y is equal to 0. So I get that 0 is equal to 1 over x squared minus 4. This has no solution. One of the best ways of seeing that is multiplying the denominator onto the other side, just like we did in chapter 6. That 0 distributes, and I get that 0 is equal to 1. X isn't even in the mix anymore. 0 is not equal to 1, so there are no x-intercepts. And you are going to see that happen for rational, or I shouldn't say rational functions, for the reciprocal of functions throughout grade 11. And then when we get to grade 12, we're going to talk about taking a reciprocal and moving it up or down, and then kind of all bets are off. But that's not this year. So you'll see no x-intercept happen again and again and again. All right, for my y-intercepts, this one's a little bit easier. My y-intercepts are when x is equal to 0. Well, that's much easier to solve. We would have y is equal to 1 over 0 squared minus 4. So y is equal to 1 over negative 4. Kind of annoying. We can write that fraction 3 ways. I can write it as negative 1/4, or I can write it as the negative kind of in the middle. All of these mean the same thing, but it is a coordinate, and that coordinate would be 0 comma negative 1/4. I actually like to put my negative on the numerator. All right, now that is often what I call grunt work. Some of that is just the background information that we need. The real benefit of doing this is to actually do it graphically, and we're going to see a lot of these things show up when we do that. Okay, to talk about the graph of this one, we're actually going to use our graphing calculator just to show how nice it is to let technology do some of the heavy lifting for us. I would recommend, just as kind of a nice default technique, that y1 is the original function, so x squared minus 4. And y2 is the reciprocal function. So 1 divided by, I really want to emphasize this. I don't want to shout, I'm using a mic, but you have to put that complex denominator in a bracket or the calculator will not do it right. So y1 is my original function, f of x. Y2 is the reciprocal of that function. Now, before we graph it, I want to quickly go to my table of values. I just actually have to reset mine because I have it all changed. So I'm going to try to make it look like your table does if it's on default. And we get something like this. Now, a lot of stuff is happening here. I'm just going to shift it up a little bit. The one thing that I would like you to notice, and it's a little bit hard to tell, is that when x is equal to negative 3, my original function is 5, my reciprocal function is 0.2. It is difficult to see this sometimes, but 0.2 is 1/5. Another example is that when the y value on the original is negative 4, the y value on the reciprocal is 1/4 or negative 1/4. That's the y-intercept that we figured out in our notes. When y is negative 3 on my original, it's negative 1/3 on my reciprocal. Look at these two errors. My y1 is 0. 1 divided by 0 doesn't exist. Your calculator recognizes that as an error. Okay, to make sure we're looking at the same thing, I'm just going to go to zoom down to option number 6, which is zoom standard. That's going to put our window settings to 10 in all 4 directions. And when we do that, in blue, it's going to graph y equals x squared minus 4. And in red, we're going to have the graph of 1 over x squared minus 4. Now, there's some pretty important stuff happening in this graph, and the most important is that because y equals x squared minus 4 has 2 x-intercepts, y equals 1 over f of x has 2 vertical asymptotes. Now, the one thing I'm going to do is I'm actually going to steal this image. I'm going to put it into my Smartboard program just so we can kind of write down some points and talk about where they're happening. Okay, it's a little pixelated, but more than enough for our purposes. Keep in mind that the blue graph is x squared minus 4, and then the red graph is the reciprocal. There's a couple things I'd like to point out here, and it is, our calculator doesn't draw these. So there's a vertical asymptote at x equals positive 2, and there's a vertical asymptote at x equals negative 2. The other asymptote, it's not vertical, is the horizontal, which is at y equals 0. And that plays a pretty big part in talking about domain and range. The other points that don't actually, we're not solving for them, which is okay, is this point, this point, this point, and this point. And all 4 of those points that I've marked down are invariant points. Now, invariant points happen when f of x is equal to positive or negative 1. One of the ways I like to show where they occur is if I draw a nice horizontal line through y equals 1 and y equals negative 1, where my blue graph hits those 2 black horizontal lines are where my invariant points will be, where y is equal to positive or negative 1. I'm just going to take those off. It makes my graph a little too busy. The only other thing I think is important, again, to recognize is to the right of this invariant point that I'm making a little bit darker, my function is getting larger and larger and larger, so my reciprocal approaches 0. To the right of that, my function gets closer and closer to 0, so my reciprocal veers up to positive infinity. But look what happens in the middle. If we look at the blue graph, it certainly approaches 0 on the outside of the invariant points, but in this section that I'm kind of highlighting or maybe making a little bit darker in blue, the function doesn't go to negative infinity. It goes to this point right here, which is at 0, negative 4. That's the lowest point or the minimum on y equals x squared minus 4. That means my red graph gets to this point right here, which would be at 0, negative 1/4. That would be the highest point on that red curve, and it's a little bit ugly to write, but if we wanted to talk about domain and range, x would be allowed to be anything except for positive and negative 2, and it would be an element of the real. So every single number except for negative 2 and positive 2. That's where my vertical asymptotes occur. For the range, it's a little bit trickier. My range, I would have to say, okay, y has to be greater than 0. That's above, but not actually on the y-axis. But it's not just less than 0, because there's a bit of a gap here. And it's tough to see in this graph, but between 0 and negative 1/4, my red curve never touches. So we would have to say that y is greater than 0 or y is less than negative 1/4, but it can be equal to negative 1/4. And then we would add y as an element to the real on. Doing domain and range for these functions is a little bit tricky. I really, really recommend you have the graph of it so you can examine that and hopefully attach a little bit of a visual to some of the math that we do in the background.